Welcome to Sustainability Management Institute's educational series on environmental sustainability and resource management. Today, we're very pleased to welcome Dr. Brandon Pierson, an environmental educator and wastewater treatment specialist with more than 15 years of experience in wastewater treatment industry. Dr. Pierson has developed and taught environmental science courses related to wastewater treatment and is an active member of the Water Environmental Federation and Breakthrough Alliance. Hello, Dr. Pierson.
Hello, thank you.
Did I miss something on your background? If so, please feel free.
Oh, thank you. Yes, so I'm a member of the Water Environment Federation. The chapter is the Water Environment Association of Texas, which I've been a member since 2016. And I'm also a member of the Breakthrough Alliance, and the chapter is Breakthrough Central Texas, and I've been a member of that since 2015. So thank you.
Well, it's such an impressive background. We're so glad to have you on our team. His scholarly research focuses on critical infrastructure, the needs within the water and wastewater sector, making him uniquely qualified to discuss one of the most important sustainability topics of our time, water recycling. Water recycling, I just can't even start to think about all the different portions, but we're going to discuss the purpose, the process, and the results. By the end of this session, participants will understand why water recycling is necessary, how wastewater is treated and reclaim, the environmental and economic benefits of water recycling, and the challenges and opportunities facing future water systems. So let's discuss the why for now. If you could just go into portions of why we need to start recycling some of our water.
That is a great question. And one reason why people should start recycling water is because water is a finite resource. People believe that a large body of water, such as the ocean, or the Great Lakes, or the Mississippi River, these large bodies of water can serve economic, social, and environmental purposes. However, due to the human impact on the environment, that water isn't always going to be the best quality. Therefore, there's times when water is not available, such as in some states where people have to purchase water from an outside provider because they don't have an ample supply of clean water. Recycling is an option available to help people receive that resource, clean water that they can use for personal or for economic purposes, serve fresh water.
So basically, it conserves freshwater resources for human beings to use personally. Right?
So I would compare water recycling, instead of discharging that water back into a stream, that water can be used for a beneficial purpose.
So it reduces the pollutant discharge as well. What about the economics of reducing water usage and actually recycling it?
That's a great question. Benefit of recycling water is the economic benefit. In relative terms, whereas retail water would cost more. And the reason why is because recycled water would cost pennies on a dollar. Retail water is more of a demand, and also because people are charging that a standard rate for retail water. Recycled water is going to serve a beneficial purpose, such as for beautification, and for economic purposes, such as water in the golf course, maybe water in the cemetery, or some other type of irrigation. In some cases, that water is going to be complementary of that service provider. So it's going to be provided at pennies on a dollar, whereas the main product is going to be their potable water that they sell at a retail value. Therefore, since it's going to be something that's complementary instead of supplementary, is to meet that consumer demand.
So it sounds to me like socially there's a positive impact as well. I do know with public health, properly treated recycled water helps protect communities from waterborne contaminants and environmental hazards. Could you expand on how it would help protect communities if we are recycling water?
Yes. In an absence of potable water after hazardous event or in some type of emergency situation where the community does not have a fresh supply of water, use that potable water for a beneficial purpose. A challenge currently is people being able to access potable water for consumption. People can use it for personal purposes, such as irrigation, agricultural purposes, and in some cases, people are injecting their recycled water into their potable water systems to add to that supply that's being treated for potable water purposes. In
Oh,
context of your question, people that are experiencing these waterborne pathogens, they can purchase recycled water in very few instances. As technology emerges and as opportunities emerge, more places will be available for that to be a reality. As of now, it's very limited. However, there is a chance for people to avoid cholera, diarrhea, and other instances by consuming that recycled water, but it's not standard as of now.
right. But in case of emergencies, it can add to the water supply and be treated and used. You can reclaim that water though, correct?
Yes, you can reclaim that water. And so what's happening is once the water goes down the drain, the water at the wastewater treatment facility, after it's been disinfected, filtered, is going to be treated at a wastewater treatment facility, and treated can be sent back to nature to a receiving stream. In that situation, nature is going to be a natural buffer or a filter. That water is going to go through the natural process and enter into a large body of water. The other option is that water can be reclaimed. Now, if that water is being reclaimed, it can be used in a facility for treatment purposes, or it can be sold to the public. In other cases, that water can be recycled back into the water system, where it's going to be added into the potable water system. As technology emerges, there's going to be for potable water use. In a few instances, recycled water can be used for consumption. The city of El Paso is developing a large system where the recycled water can be used for potable water purposes. After the treatment, that treated effluent can be used as potable water. Detergent and all of the other contaminants in the water are removed. Once it's removed, it goes through the filtration, disinfection process, and then it's sent back into nature.
So as I see it, the water that can be recycled comes from many venues outside of even the home environment. It can come from restaurants, hotels, office buildings, retail facilities, industrial sources, manufacturing, chemical production, food processing, and energy and runoff, rain runoff, urban drainage systems. Let's talk a little about the contaminants found in this water that you can recycle. One is suspended solids, which are the particles that can reduce water clarity and interfere with the treatment process if not removed. Are there other things found in this water?
Yes, and a lot of things are going to be found in water. An implication of the human impact is the properties of the wastewater. Water that's used in an industrial complex would have certain properties such as elements that's in heavy metals, maybe detergents, or some type of chemical. Water that's used in an agricultural facility may have properties such as nitrogen, phosphorus, and other types of elements. Inside of a residential area, there's going to be more biological waste and more waste such as properties that's inside of food. So there's going to be a variety of properties in wastewater. And as I stated, depending on the user, the water will have certain properties.
One thing I didn't even think of is personal care products, not just soaps, but lotions and hair conditioner, things of that nature. Everything that's put into that water needs to be removed during the process, correct?
It does need to be removed. And for example, wastewater treatment facilities were not designed to treat certain products. They were designed to treat stuff that goes down the drain. So things such as medication, fats, oils, and grease, and chemicals. The wastewater treatment facilities were not designed to treat those substances. However, as technology emerged, these systems became so effective that they can remove many of the uncommon contaminants from the water. And the reason why technology emerged is because leaders in the wastewater industry understood the need to remove these uncommon properties because there was such a significance of medications, fats, oils, and greases, chemicals arriving in the treatment facilities, and they were impacting the treatment process.
So when you say treatment process, there's more than one portion of that process. You use different types of screens and what type of debris it takes out or materials.
Yes, so your preliminary treatment will remove the large debris. So things that flow naturally in the water that's large and doesn't really need to be in the water, such as leaves, grass, vegetation, any type of large objects, large solid objects in the water. There's going to be a screening process that removes those large debris. The primary treatment process is going to remove the smaller substances, silt, dirt, sand, any type of particulate matters that's going to need to be removed from the water, that screening process is a advanced method that removes the smaller part. Anything else that passes through the water needs to go through a sedimentation process, whereas the water undergoes some type of chemical or natural process where the materials settle and can be removed with equipment. Once those solids are settled, anything that's not settled in the water will go through the filtration process. The filtration process precedes the disinfection process. The filtration process is relative to filtering water at their home. So the sludge removal process happens right before the filtration.
Okay, so that happens first, then the filtration. Well, that's good to know.
Yes, and then the disinfection process. Yes.
Right. Can imagine all the different debris, and now you're talking about the filtration. So there's so many different things. Do you use any activated carbon in the process?
During the treatment process, activated carbon can be used, and the reason why is because it's going to capture different types of elements. All elements are going to have their own properties, and activated carbon, activated sand, they're going to be substances that capture these substances with different properties effectively. So the end result would be water that's clear for disinfection without a lot of grit, sand, suspended solids. Few things are going to pass through the filtration process or dissolve solids.
So you use a membrane process to capture all the tiny particulates, and then the reverse osmosis. Do you use that too?
Such as maybe alcohols, anything that's dissolved, super dissolved, needs to be precipitated out. The reverse osmosis process, from my experience, that's used for in-house purposes, used for laboratory or for some other beneficial purpose within the facility.
I know that there's different types of disinfectant methods. There's chlorine, UV light.
Yes, ozone and wastewater treatment is not a common,
which I believe very strongly in ozone treatment. Do they use that as well?
Product is more used in potable water treatment. UV light is going to be used in wastewater treatment and in potable water treatment. And one reason why is because the safety of UV light, but also it doesn't produce a byproduct. Chlorine is the most used, and some will argue the most economical, and it's something that's traditionally used in wastewater treatment. But yes, ozone, UV light disinfection, and chlorine disinfection are methods used in the treatment process.
I like that the UV light, it destroys the microbial DNA within the waters. When we're dealing with epidemics, it is used most of the time.
Yes, one thing about UV light that differentiates from chlorine is something that destroys the DNA of bacteria. However, UV light, it fractures the DNA, but it destroys the reproductive system of that bacteria. So the difference is that a chlorine bacteria can reproduce in 5 minutes, and it takes 15 minutes to destroy that bacteria. Well, within that 5 minutes, bacteria can reproduce, opposed to UV light that fractures the DNA, however, destroys that reproductive system to where it's not going to be able to reproduce. So it's a little bit different in the treatment process. They both are effective, but they're effective in different ways.
I'm just going to ask a very simplistic question, but I know it needs you to answer it. So for the monitoring systems, bacteria, viruses, nutrients, what else do you monitor for?
The aesthetics is very important. So water should be translucent. It should not have a pungent smell, and the actual texture of it should be natural, like a fluid. So the aesthetics of the water is very important. People are looking at if the water is translucent, they can see the reflection, or where it's not cloudy, or what they define as turbid is more clear than it is turbid. So there shouldn't be any type of sand, silt, or any type of small particulate matter in the water as it's leaving from the treatment process. And then also, as I stated, it should not have any type of film. It should be just as the properties of potable water. Also, water should have a natural smell, maybe a smell that people get from their potable water. It should be the same. In some cases, there may be some small residual smell of chlorine if the chlorine being used, but for the most part, it should have the aesthetics of the natural potable water. So those are some of the things that's also being monitored in the system.
So when all is said and done, the recycled water can be used for some things like crop irrigation, orchards, vineyards, landscaping. When it comes to industrial reuse, it can be used for cooling towers. Are there other industrial systems it can be used for?
Yes. So water that's reclaimed from an industrial facility, could also go to a centralized wastewater treatment process. It can be used for the same beneficial purpose, similar to where water from a commercial industry is used for a beneficial purpose. So industry is a very broad term that can include large facilities and small industry facilities. Some places they treat their own water because they don't discharge to a public system. In those cases, they would use their own water. In cases where industrial users are sending their water back for recycled purposes, that water can be used for irrigation, it can be used for agriculture, it can be used for beautification, and then also for, like I said, landscaping as well too. And like I said, the reason why is because that water can be sent to a centralized wastewater facility or to a remote wastewater facility that can treat it to a level that's conducive for beneficial purposes.
I remember talking to an engineer recently, and they said that they use recycled water, reclaimed water, as they put it, for their boiler systems. And I was really surprised, but that's wonderful. There's so many uses. Environmental restoration, even wildlife habitats, wetlands, stream flow maintenance, ecosystem recovery, to reduce freshwater withdrawals. Obviously, it helps to conserve the fresh water if you're using recycled water more. And I feel that that's very useful, especially when you hear about the Colorado River and the Arkansas River and how low they're going and buying and selling water. And here we can recycle so much of it.
Yes.
Wonderful. And then it helps with enhanced water security, improved sustainability, greater climate resilience, because the recycled water systems help communities adapt to changing weather patterns and water availability and long-term resource availability to help, like I said, conserve that water. There's so many different things it can be used for, especially with the population growth and the way it is. You had mentioned technology a little while ago, and I was wondering, could they use AI intelligent monitoring or sensors or
Use technology in the wastewater treatment industry? And the reason why is because
predictive maintenance in water recycling process?
yes, and that's a good question. And AI technology has been it is compatible with the plans that people put in place for monitoring these systems. Some systems they monitor in remote areas with AI technology, and some systems they can monitor within a facility with the AI technology. Very exclusive AI software can monitor remote areas and the facility. It's more of a one-stop shop for monitoring. The system that's mostly used is known as supervisory control and data acquisition, SCADA. That is a common used AI technology in the wastewater industry. And the reason why is because this system can perform the duties of an operator or a person that's monitoring the system. Once that supervisory control and data acquisition system gets a command, it's going to fulfill that command. And people program these systems to alert, to respond, to adjust, to maintain, and to operate different parts of wastewater treatment process.
That makes me think of the real-time water quality analytics with the continual analytical monitoring that provides immediate feedback on the water quality and conditions, and it enhances operational control and public safety because you have these alarms and everything that tell you if something's not quite right. And everything is so highly controlled. It is wonderful having you here, and I so truly appreciate everything you do in that industry to protect societal health. Water recycling represents one of the most practical and sustainable solutions for managing our future water needs just about everywhere. And by transforming wastewater and as a valuable resource, communities can protect fresh water supplies, strengthen infrastructure resilience, and support economic development with safeguarding environmental health. As populations continue to grow and water sources face increasing pressure, water recycling will play an increasingly important role in achieving long-term sustainability. Thank you very much, Dr. Brandon Pierson. You know that you are the author of the book that we use for training, and your knowledge has just blown me out of the water when writing that book. So we do appreciate you and your expertise. So on behalf of Sustainability Management Institute, thank you for joining us. Have a good day.